Hello and welcome back to another edition of PChem is Hard. Today is going to be the part 2 of Perfect Gas Law where we're doing an example problem. This is from Dr. Atkins' physical chemistry book, chapter 1, section A. I think this is the first problem. So let's roll up our sleeves and do some chemistry. We're going to begin by reading the word problem and highlighting some important information. So it states, could 131 grams of xenon gas in a vessel of volume 1 decimeter cubed exert a pressure of 20 atmospheres at 25 degrees Celsius if it behaved as a perfect gas? If not, what pressure would it exert? Whew, that was a mouthful. So right off the bat, we kind of see the formula in place. What it's asking is, do these parameters behave as a perfect gas, and if it doesn't, what pressure would it exert? So let's go ahead and mark our important information. This is 131 grams of xenon gas. Our volume is 1 decimeter cubed. Our pressure is 20 atmospheres. And our temperature is 25 degrees Celsius. Let's do a couple quick conversions. Actually, before we do that, let's go ahead and just write out, just for practice, good practice. This is the formula we're going to be using. This is always a good thing that I do when I take a test, is I read the problem, figure out what formulas I'm going to use, write them up, and I can see relationships between different formulas easier, you know, almost like you're making a flow chart of sorts. Our temperature is going to be 273.15 plus 25, and this is just to convert it. This is to go from C to Kelvin, so Celsius to Kelvin, and this is going to be 298. Whoop, what did I do there? Let's go ahead and erase that guy. I tend to see 298 a lot when I do my homework and my test. I'm not sure if they just like 25 degrees Celsius a bunch. I think they do. It's pretty close to room temp, I think. I could be mistaken. So this is 298.5 Kelvin. The other thing we need to convert, but it's not really a conversion, because once you look it up you realize that xenon gas is 131 grams. That's its atomic mass. So this is just going to equal 1 mole. And that's going to be really nice because it's going to help us with our calculations. So we just need to note that's 1 mole, and we can start defining our variables. I'm going to leave P the variable we're solving for, because this solves both questions. If it does act like an ideal gas, it's going to produce a pressure of 20 atmospheres as the parameters have given us, and if it does not, it's going to give us the second question. It's going to tell us what pressure it does exert. Our volume is going to be 1 decimeter cubed. Ooh. Volume is done in decimeters in physical chemistry. That is an interesting thing, and it is something to note when you're converting units, just to remember, because we don't typically see that. We most of the time see meters, centimeters, and millimeters, and you'll see those here too, but decimeter also comes up quite a bit. And if you recall from last video, the constant is 8.314. The temperature is 298, and I'm going to bring up my calculator here, and I encourage you to go along with me just so you get it feels right, the muscle memory. That's what it is, muscle memory. So we pretty much just have 8.314 times 298.15. Okay, so as we can see, this does not equal 20 atmospheres. This is a much more pressure. And as we know, the ones go away. So pressure is going to equal, what was that number? 24, yeah, 2478. You see 247, 2478 atmospheres. This is a much larger number than 20. So we know real quick that number one, it is not an ideal gas. As most real gases are not ideal. This is something that only comes about with things that are very, very low pressure. And then we know that our pressure that we would exert is this guy right here. So, I hope this has helped you. Thank you very much for watching. Please like and subscribe and share with all your study mates. Leave some comments, shoot me an email if you have any questions. I need more questions to answer. And I will see you guys later. Keep on keeping on.